tried to get tickets so badly that I made every single staff member that I knew also sign up for me and every single person that I knew and my parents and my sister and everyone tried and no one got the code. So I wish that I was supposed to meet her on the street somewhere. Probably with Canada.
Okay. Red for acids, blue for base.
Are those three dots mean therefore?
Yep. If you're writing, those mean therefore. What do those mean? Because. Speed up your writing. Any particular acid, if we have HX and it is in water, what does it produce? Based on that generic reaction. H3O plus, because it's a proton donor, and X charges minus. I'm going to be stickler about charges, mostly because you're going to get slapped with them continuously all the way into university if you keep dropping them, because they change the compound of what it is if you leave it off. HX plus H2O goes to H3O plus. This is for every acid. So this is the ultimate product for every acid. It is what acid is. It's like asking what's worth more, gold or money. And clearly money is worth more because money is what you translate gold into. Asking if which is stronger, a strong acid or H3O plus, it's like, well, we measure how strong an acid is by how much H3O plus is. And so sometimes on the table you'll find H plus in a different spot because they're doing the water equilibrium, or you'll find OH minus somewhere and students will make the mistake of thinking, oh, that means it's weak because I found it in this spot. It is what we're measuring it with. H3O plus is what we measure acid with. There cannot be a stronger acid than H3O plus. Similarly for OH minus, if we have, let's go B, because we don't need any more than that, plus water, what does the average base be? OH. And then what would, it's a little trickier than that one, what would B be in this context? HB?
Yeah.
Charges? Plus, nice. Hydrogen has to move, it adds its charge, adds the H. This is very similar to NH3 plus H2O goes to OH minus plus NH4 plus. A B could easily be NH3. A lot of the bases would have a negative charge and that would become on the other side, but as long as you're changing it, it doesn't matter. Once again, this is how we define a base. We define the strength of the base by how much it produces hydroxide. We've redefined acids and bases as proton donors and proton acceptors. The old definition was proton donors and hydroxide donors, which made a lot of sense because it turns out this actually is the thing that all bases make. But they're related not through hydroxide being a particular type of thing, but because this is what water does. I should put a 2 in front of that. H4 plus. At a very weak level, water separates into H3O plus and OH minus. Or you can write it in the simple form. H2O goes to H plus plus OH minus. We've told you that water is covalent. It doesn't separate. It does. It's really small. It's 0.1 with like 13 zeros and then a 1. So acid-base chemistry, it turns out, just revolves around this reaction. And the reason we spent so much time on Le Chatelier's principle, and then we did solubility, you need solubility to understand why some bases are bases, like strontium hydroxide is a strong base because it's soluble. If you increase the amount of H3O plus, what will happen to the amount of hydroxide?
Decrease.
It will increase as well?
Or decrease.
It'll decrease because it'll shift that way. And so pH is a measure of this equilibrium. And so that's why we will also talk about pOH. They are inseparable. This is a pure liquid. Will we include that in our KAQ? No. So these are the only two things that will end up mattering. So the reason why acid is H2O plus is the strongest acid and OH minus is the strongest base is ultimately because they are the participants in this particular equilibrium reaction. This is all of acid-base chemistry. Anything we add is just adjusting these levels back and forth. We measure the strength of an acid by the amount of H2O plus. We measure the strength of the base by the amount of hydroxide, because that's the equilibrium that we've called acid-base. If you are engaged in dihydrogen monoxide chemistry, as water-based creatures that we are, then that's going to be the most important reaction to you. It's only important because of our particular reactions that we have. We have a lot of water chemistry on planet Earth, different planets, different importances, but it's going to be hugely important for all of chemistry. So this is more of a definition page, and it's to also stem the students who will go down here. There's always a couple, and we'll go, oh, I guess hydroxide, it's not in the gray area, so it must be a strong weak base. Or maybe H plus is here, so it's a weak base. And no. This entire table is written as acid-base reactions. This side is the base. It is only referring to that. This side is the acid. And they show you for convenience the water reaction, which is what either of them are. None of those are considered. These are acid or base. That is the ultimate acid. That is the ultimate base by definition. They're not considered in sort of this type of scale. Similarly, this is solely there so that you can see they are in a 1-to-1 ratio. So this is one of those true by definitions. This is how we define our chemistry so that we can then make calculations on it. Questions?
What's the
Concerns?
mistake that people make with that?
Pardon?
What's the mistake that people make with that?
People have gone during a, say, test or a quiz, and I've said, name me a weak base that is strong. So if I said right now, pick out a weak base that's strong. Where are the strong weak bases? Top or bottom? Bottom. It labels it there, it's weak. You go all the way down, and I say a strong, weak base. And they go, oh, on this side, strong. Here's the gray line. Hydroxide is the strongest weak base. It's like, no, hydroxide is what base is. That is the strongest of all bases. Or they'll do this, and they'll say H+, which is what acid is. So it's a matter of labeling. You have to know when you're using this table, the reason that is included is so that you can look at its KQ. Not because that in any particular way is weak, that's just what water does. When it's by itself, nothing else is around. Good?
So when like you react an acid, the only acid that's left is like pH+.
Yeah. If it's a strong acid. If it's a weak acid, you'll get acids on both sides. So if you, we're going to do that next actually. React some acids and bases with each other. We had conjugate acids and bases before. Why don't I continue the green thing here? When we talk about whether something is strong, strength is the extent of its ionization. I think I had an example reaction. Where did I write? Oh, so, if I have CH3, COOH, acid or base?
That's neutral.
It's neutral right now, but if it's in water, is that acid or base?
That's an acid.
It's an acid. Everybody should have their tables out in front of them. You're going to need your data table on that acid-base table this whole time. Makes everything a lot easier because all of them are labeled. You can find that on the acid side. And the other one, I'll give you a, oh yeah, nice boric. So we've already established this is the acid. Could that be an acid?
Yeah.
Yeah. Could it be a base, just by looking at it?
Oh, yeah.
It's got a hydrogen, so it can give off, but it's also got a negative charge, so it can accept. You'll find it on the base side of your table. But if this is an acid, and that could be either, but this one can't be either. So that means that is forced. That is our base. Write the products. What are we going to get?
Wait, how do you find H2BO3 on your table?
You,
I don't.
it's on there. The only thing I can say, like, how do you find it? They're not in alphabetical order. You just have to look for it. And found it, but I cheated because I've looked at the table so long I know where it is. Do you see it? Yeah, desperately trying to show you where it is.
Oh yeah, I see it.
Yeah.
But it's on the acid side.
What?
Where I just can't.
Right there?
Oh, never mind.
Its compatriot is on the acid side, but it is on the base side. It could have been an acid, but it's not. I've looked for on the left. I can't find it. So it doesn't act as an acid apparently very often, if at all.
You move the H over from the
Can
acid.
we go back?
Yep.
This is the only thing acid has it in H, and H has to be used to. So you
So then, what are our products? Thomas, give me one of them.
H3BO3.
Excellent. And is that an acid or a base?
That's an acid.
That's an acid. So we have a first conjugate acid-base pair. And someone else for the other one. Yep.
CH3COO.
Yep, I just need you to finish that. Say it.
Minus.
Minus. Excellent. This whole side has one negative charge, so this whole side has to have one negative charge. Always do a little check. And that, Nicholas, is an acid or a base?
Base.
Base. So then we have an acid-base reaction. We have an acid reacting with a base, which gives the conjugate acid to the base and the conjugate base to the acid. Where will the molecules spend most of their time in this equilibrium? Without even knowing the KQ, you can figure out where most of the molecules are by looking at the strength of them. You could do it with KB, but we have a Ka table. So on our table, we can just look up the strength of things. Which is stronger, this acid or that acid?
The second one?
That one?
Yeah.
How do you know?
Because that one got an H in the process.
Oh, I wrote this in an arbitrary, like that one is on this side, but I wrote this in an arbitrary way. I could write it the other way, if that's what you mean. I don't know which one is stronger. Yep.
this is like something completely different, but how is NH3 and this can't give off OH? Because it doesn't have any OH.
I will answer that question after we're done with this one. Right after, because it's a good question. However, does everybody have the table in front of you? Examine your table. How can you tell the strength of acids using your table?
Okay.
Did you say AA?
Okay.
Ka. You could. We haven't actually introduced Ka. You could do it relatively, but it's in order of Ka. We have
The CH1's stronger.
the Ca. How do you know?
It's based on the table.
Based on the table. Strength. Strong up here. Weak down here. And we just find it there. Now this is on the left, this one's on the right. If this one's stronger, where are the, and this one's weaker, where are most of the molecules going to end up?
Products.
On the stronger one.
On the stronger one. Why?
Wait, what?
Yeah, wait, what?
Shouldn't it be to the
product
weaker
side.
one because that one's the one getting the hydrogen?
Yeah, I mean, if you're stronger, you're gonna throw. Remember when we had the wall of equilibrium, and we threw stuff back and forth? If the side was really good at throwing stuff, did they have any ammo? No, it all ended up on the other side. So the stronger one doesn't end up with any ammo. It all ends up on the other side. So the weaker side ends up being the favored side. If a strong acid or a strong base products are always, right, because if they're strong, they're 100%. HCl goes to H plus the Cl minus. So that a 0.1 molar HCl is 0.1 molar H plus. So obviously products are favored for a strong acid. Same thing here. If it's a, what does WA or WB stand for, since I abbreviated?
Weak base, weak acid.
Weak base, weak acid. Acid, base, weak. And so if this is stronger, most of the stuff ends up here. And the only reason I think students confuse us is because of the English language and the word favored. Like there's some mental block or bias where we go, oh, they're stronger. We're supposed to like them more. They're favored. No, stronger is shoving things to the other side, so it ends up, that other side ends up with more stuff. So favored chemically just means more stuff on that side.
And when you determine that, you just look at the acid.
Yeah, look at the acids. You could look at the bases. You'll come up with the same kind of effect because if you end up with a strong acid shoving it to the other side, you'll also find out its conjugate base is weaker because they're both joined through that water equilibrium. Yeah. So right now, identify the acid and the base in this one, and tell me which side is favored. I'll ask someone which is the acids, which is the bases. Look them up. Max, what do you think? You're not taking. Put that way. You're not taking notes.
Yeah, I think it's H2O4 F minus with bases.
Oh, and I forgot to answer your question, Glenn. Glad, right after this one, remind me.
Okay.
Or just go back one page after and look at the page. Because I think I wrote down NH3 is the reaction. Because the quick answer is that it does give off hydroxide,
But it doesn't have it in the,
but it does give it off in water.
or just like get it from the water.
Yeah.
Oh.
Because it's a proton detector, it takes it from the water and then the water becomes hydroxide. Yeah.
That answers it.
Okay. Max, I'm going to pick on you. Identify the acid bases.
Just trying to figure that out.
That's
Those. Base.
is the base what?
HL.
Well, that one, probably not because there's no minus charge. Bases usually are negative, not always, because NH3 isn't. Is there anything that only in here that can only be one of them, like either an acid or a base? F. And what does that have to be?
Base.
And so its opposite would be the conjugate acid.
Okay.
If that's a base, what's the other one?
Acid.
Right, I'll do different colors. Yeah, and then we identified our conjugates. Now just compare acids. Josh, do you have your table? Can I ask you?
Yeah, go ahead.
Which side is favored?
Product,
Favored side. Why? Because it's weaker. H2PO4, if you look on your table. Whereabouts is H2PO4?
It's like the bottom is.
Like near, it's, there it is, in green. And HF is like super strong. It's a strong weak base. So the opposite side is favored. We know. Practice. This is more like just looking at it and doing it, so I didn't want to have you running to the board, so I'm going to try this again. Starting activity, go to hellosmart.com
Oh, yeah.
and type in 897683.
Oh, I like this game.
How are we going on? Try it. Yeah.
Like Hello Fresh.
Well, what's it called?
Hellosmart.com. Oh, I'll go rate that up too. And I was going to play Kahoot music, but then yesterday in the other class, we found Zebra Man by Bob James.
why don't we just do good?
And it's the most 88 thing I've ever heard in my life.
Why is there just a gray box on it?
Oh, because when this prints, it just prints a gray box.
Can you show me what it's supposed to look like? Mine's come up with
Yeah.
What?
Oh, are we starting?
Yeah, you're starting. Go.
Wait, do we have a?
Where is this?
Wait a minute, where is it? Hellosmart.com. Hellosmart.com, type in this code.
Well, I got this smart ego.
Well, you're looking at the right question. Because there's more than one question. If you want a different question than others, I can see that happening. Like if I was in question 2 and your own question 1.
Oh, this one.
Join. Is anybody having problems joining?
Well, I have.
Okay, Sonia's in the lead. Well done.
H2S is the first question. Oh no, it's lower. H2S. Oh, okay, so it's B.
Yeah. Do you know about that? 44%. How close are we? Using your table, looking things up, carefully writing down numbers.
Wait, you said favor as in like it has to be on the small side.
It has to be on the what side?
Smaller side.
What do you mean?
What if it's
small?
like one below? Like what if the acid is like
The weaker acid, yeah.
What if the
Smaller
acid,
can have different connotations. So.
what if the acid is like barely weaker, like HCl2 or HL?
If one acid is very weaker than the other,
So when you put beside your name,
yeah.
so I look like a blood spot.
Done. Almost done, Andrew? Taz, almost
Wait,
done.
Mr. Neufeld, you giving us a quiz. A test.
Oh, did I mention when I was giving you your test?
No.
Okay. Next class, I'm going to give you a sheet of paper. I'm stupidly wrote in comments on the gradebook, which I couldn't export. So what I've created a sheet, and I just have to figure out how to export it. It's going to give you your proficiency in communication, your proficiency in critical analysis. It'll also tell you how well you did relatively in reaction kinetics, equilibrium, and solubility, so you can use that for gauging your study for the final exam. Your next test isn't going to cover this material, it's just going to be on acids and bases. But your final exam covers all the material, which is one of the reasons we go cumulative. But we're going to start over again right now with cumulative. Will be the first part of acids will be your first test, then more acids for the second test, then eventually
So
do a
right
test
before,
like
so
acids.
right before the final exam, we're gonna have a big cumulative for all this stuff, and then we're gonna,
For all the acid stuff.
so we're gonna how close that can be found.
So your final is the only one that will cover the entire year.
Yeah, but how close are the two tests gonna be?
They might be reasonably close. Yeah. I mean, you'll be studying for the final anyway, so. So I hope to have that ready to go. In order to pull it off of things, I learned some Python programming, and I think I'll have something ready for you, but it might look a little rough. I'm also going to have a very rough draft of your report on there. Because sometimes I want to tell you how you're doing, and then a student comes up to me and said, my parents will kill me if you phrase it that way. So you have a chance to pre-look at it and make sure that the comment is fair. There's nothing that I put down that wasn't fair. Or I can reword things in a different way. It is very rough. This is the draft that has gone to a reader, and I'm actually not done tweaking some of them first. But you'll see a draft of it. I'm going to ask for you to hand it back. And at least, though, you'll get to see it before you publish it. Okay, I think we should be all done now. Is anybody not done? Quiz them away. And not done.
Gotta wait for answers.
Pardon? You have like so many screens.
Bro, my grade
Because it's not submitted.
I can see how they should, so I was just like,
Okay. Is everybody done? Or close to done? 5, 4, 3. Ashley, have you done them at all? It says you didn't. We'll see if you pop up. Hopefully it marks it on yours even if it doesn't. I'm going to hit end. And I'll stop the music. Okay, first one.
Wait, so many people.
The vast majority of the people picked B, so I want to double check this answer. Which side favors the formation of products? We have HNO2, HIO3, and HCO2. Formation of none of those are strong. Those are weak. Those are all weak. So it says A. So HNO2 and FA.
HNO2 is.
That's gotta be a mistake.
Clear ink from page. Where's HNO2?
Right above HF.
Nitrous.
They're next to each other.
HNO2?
Right above HF.
Oh, okay, there. HNO2 and not that one.
I'm not very happy with
Go, load. HNO2 and F and HF, and then
So it looks like A is right.
I guess A and
and HF is on the product side. That's on the this is on the product side, and that's on the reactant side. That one is stronger, so the products will be favored. Now let's check the one that everybody else picked. Everybody else picked B. So let's see if I included a second right answer on there. We have H2CO3 and HIO3. So where's H2CO3? Near the bottom middle. H2CO3 is here. This is on the reactant side. And what's the other one?
The other one?
Yeah, what's the other acid?
HIO3.
HIO3 is here.
Second highest.
And that's the product side, right?
Yeah, so that's like the.
So which side is favored if that's the strongest one? The reactants. So the error there for the very first one is what I suspect you did is you found the strongest one and just picked that side instead of going to the opposite side. You picked the weakest side. Let's see if this is consistent across all of them.
When you,
Yep.
I put A,
Yeah.
but it says like a red cross next to it.
HNO2 plus F minus.
Yeah. I don't know why, but whatever.
Happened to me last time.
Yeah. And it says Frosch. Oh, I guess that's German.
Yeah.
Oh, it gives you the German one? That's really cool. What happens if you, what, does it give you a right one?
No. It just says I did it wrong, even though I did A.
It's favored if it's
Or whatever.
Oh, yeah. Well, you know in your heart of hearts you're right. I know that won't bother you because you're an independent person. Okay, next one. According to this, everybody picked everything, yo. I looked this one up for the other class, so I'm pretty sure this one is in fact. Which of the following are the reactants favored, which means the strongest acid has to be here in the products, which means I think H2CO3 is much stronger than H2S, so that's definitely true. Is HCN stronger than HNO2? I don't think so. And is NH4 plus stronger than H3O plus? I don't think so. Tell me if I'm wrong, but HPO4 minus 2 stronger than, no, that's quite a strong. So this is the only one in which the stronger one is on the product side.
You mean reactants?
No, we want reactants favored, so we want the strongest acid on the product side. So that makes the reactants favored. Those who answered C, D, or A. Does that make sense? Cause, okay, let's do another one. Hold it, did we do another one? Nope. Okay, compare the relative concentrations of HCl plus or OH minus between two acids using their positions on the table. We had to do that just now. For this one, for the last one, you had to look up relative strengths. This is using that particular knowledge again. Which one of these would have the lowest concentration of hydroxide? What is that asking you? Which of these is the weakest base? Which one's the weakest base? Why do we have sodium in front of all of them? Just so it's soluble and they're neutral? I could have easily done it like this. And just put commas between them. That would have been the same question. There would have been no difference in the answer. But you were often presented with compounds that are whole and neutral. So if you went to buy it off the shelf, you wouldn't buy HPO4 minus 2. You'd buy sodium hydrogen phosphate. So the sodium is just spectators. Oh, that's weird and creepy version. Done. Okay, which one's the weakest one? I want a show of hands then. Weakest one being fluoride. Weakest one being chloride. Weakest one being hydrogen carbonate or bicarbonate. We got one vote. Only one person's voting so far, so I'm assuming you're all saving your votes for hydrogen phosphate. Everybody automatically voted because to not make a choice is to make a choice.
Wait, which one's the strongest?
Which has the lowest concentration of hydroxide? So is that strongest? Lowest. Weakest.
It's the last. The weakest? Oh,
It's the last one?
We want to guess last one.
HPO4 minus? Let's take a look. Where are the weak bases located?
At the top part.
Top part? Which side? Left or right?
Right.
Right.
Lion.
Right. So, read out the ions. What's the first ion?
Give me both sheets. I don't know. Wait, what were they?
NAF.
No, just the important ion. Don't give me the spectators. F. F minus. What else?
CL.
Cl minus.
Oh, CL is the strongest.
H. What?
The next class.
H2PO4.
H2PO4. Okay. Wasn't it HPO4?
And it's HPO4.
Yeah, it was HP4.
Where's HPO4?
It's like near the, like it's,
Is it further down?
yeah.
HPO4 comes out here. And what was the next one?
HCO3.
HCO3. I think that's a little higher.
You're about to pass it.
It's
near the bottom.
Oh, there it is.
between us
So of all of these, which one's the weakest one?
and
CL.
Yeah. And then, somewhat of a trick question. Can this one ever even be a base? No, it's here on the other side of one-way arrow. It is so weak it won't provide any hydroxide at all. The only hydroxide in there will be that from the natural dissociation of water. So this is absolutely the weakest base you can have in the solution because it's so weak it does nothing. Have you ever been in a group and there's a member who just ghosts you and then shows up to present and they haven't done any work? That's chloride. It says it's a base, but it's not. So, that one. Table orientation reminder. We've got, for bases, weak, strong, acids, strong, weak. Let's try that again. New one. HelloSmart.com 897683.
Wait, what was the answer for the last one, sorry?
CL minus.
What is that website called again?
Hello, smart.
Hello Smart.
Why is it
I don't know why sometimes it puts like a little red thing, phone next to it. But there's lots of people on their phones where it doesn't do that. It's like, I think it indicates like it might have disconnected or something. Yeah, when they reconnect, I think it disappears.
Oh wait, are we doing another one?
Oh, yeah, you're right.
Yep, we're doing another one. Hmm? Well, HCl plus, what is that, acid or base?
Which one's the most?
Acid, so you're looking for the most strongest acid or the weakest acid? No, NaCN is the thing.
Oh, it's a thing.
Yeah. That's sodium cyanide.
Oh, I
And cyanide is a weak base.
What's your name so far?
Yep.
NO3 anywhere on the
If you
table?
don't have.
Yep. Look up. Look way up.
What? I.
Did you say NO3?
Yeah.
Oh,
I'm not in anymore.
hmm?
I'm not in anymore. No, it doesn't let me. It's a German one.
I don't know what it says.
Hi Theo, please wait until the teacher starts the lesson.
Just go to hellosmart.com. Say that again. Because it's obviously not. It's probably the network cut you off. And then
Okay, so what does it say? It says NO3,
and then I'll raise up the top.
oh no, was that lowest wage was, TCM.
So like NO3 is the actual base, but I
Okay, Jimmy, wherever you are. Taz?
Yeah.
Almost done?
Yeah, a little last one.
I need a bit more time.
And Ashley, you done? And Theo, I see your second one up.
You guys just like come on that.
Pardon? Go.
10 more minutes.
Not 10 minutes. We're finishing what we're doing today, whether we go into the pass the bill or not. So.
Oh, that's fine because we got English next.
For the chemistry all break. And then into the next class.
I'd be down.
Can we do chem until lunch?
No, I have another class
Yeah,
coming in, so I'd have to get you out.
Let's
after
do a
that.
class
10
call if we
minutes.
should just do this all at the end of the day and not go to English.
Not doing this. Just keep
Yeah.
drawing.
we should have
Well, this is a good class, and we should do this on
English.
I did that myself.
Whatever you can do.
Okay.
I don't know.
Looks like most people are done. I'm going to give you 5, 4, 3, 2, 1, end. Nice. One person picked HSO4.
What?
HNO3 is a strong acid. It's one of the top 6. So it will have the highest concentration no matter what. Oh, I need to scroll down. Number 2. Which of the following solutions will have the lowest concentration of hydroxide? NO3 is the conjugate of a strong acid, so it is not a base. It's a base in name only. So all the other ones will actually react with water and give you some hydroxide. That'll give you none.
2.
And nice.
I got all of them.
Which will have the highest? So which one of these is the strongest base? Phosphate is indeed the strongest base above cyanide. NO3 is the weakest, and SO4 minus 2 is actually reasonably strong, but not as strong as phosphate. 5 people didn't answer. You terrible, terrible people. Also, that's more people than we have in the class, so I don't know what's doing.
It says that it's wrong, even though.
Yeah, some people were noticing that. I don't know. What number are you on?
I was thinking about it.
3? And you got that right?
Yeah.
So you can look at it and go, oh, I was right. I don't know why it does that. Ooh, I can export results.
That's why we do Kahoot.
That's new.
Should I take
Let's see if it thinks that you're wrong completely. Nope, that is neither of those things. Oh well. Okay. Music be quiet. Next one. More questions. We already, this learning outcome re-explains what amphiprotic is, which we already did. So all I want to know from you is, which one of those is amphiprotic? This is not on a little pad or anything. Just close those down. 1, 2, 3, or 4. Is it one of them, two of them, all of them? Which ones are amphiprotic? So what does amphiprotic mean?
Can give and take protons.
Give or take protons.
One is
Because they both got a charge. And they got an H.
how can it take a proton?
The first one is
The first one doesn't have an H. They used to give off something.
Okay. Show of hands. Roman numeral 1, PO4 minus 3. Amphiprotic? No votes. 0. HPO4 2 minus. 1, 2, 3, 4, 5. 5 votes. H2PO4 minus 1. 1, 2, 3, 4. Same votes.
Yes, yes.
Yes. H3PO4. 0. Of the 10 of you who voted, yes, those are the two amphiprotic ones. They tend to have the formula HX minus. Bonus question, which compound has the formula HX minus but is not amphiprotic? That you were warned about. Much like your parents warned you about stranger.
HSO4 minus.
HSO4 minus. Why is that not amphiprotic?
Because it's too strong to acid.
Which acid?
H2SO4.
H2SO4. So H2SO4 is a strong acid. It's a one-way arrow. It makes this. So this cannot accept a proton. This is only an acid.
What's amphiprotic?
It can both accept and donate a proton. It's both an acid and a base. You'll find it on both sides of the table.
The easiest way of telling is just like have an H and a charge.
Yeah. That's the easiest way of telling. As long as you know that that's the exception and remember, then it makes it really fast.
Wait, what makes that the exception?
Because that's the opposite of H2SO4, which is a strong acid. So this arrow is one way. So this can never be a proton acceptor.
Wait, but what about if it like what's are there compounds that like don't have an H or a charge that are amphiprotic as well?
If I search for compounds, more of them, yeah, I could probably find some that have H's that would fool you, but confined to your table and the ones you know about. That's the main exception you have to know.
What about like NH3? Would that be?
Is it amphiprotic?
Yeah.
Why?
No.
They can't give up.
They can't give off. In fact, NH3 can't because it is here and it always goes one way there. NH3 cannot go back that way.
Oh no, I was looking at where NH3 is a base.
Yeah, but can it act as an acid?
Okay.
To be amphiprotic, you have to be on both sides. Here it is. It cannot act as an acid. Right? You can find on the base side. Similarly, hydroxide can never give up that hydrogen. So hydroxide fits that. That's HO minus. But can it give off that other hydrogen? No. It's on the opposite side of a one-way arrow for O minus 2. Does that make sense?
Wait, why
Okay.
can't H3PO4 like give off an H?
It can.
It can't.
It can't accept one.
Oh.
So
To be
there is no
amphiprotic.
H4PO4 plus.
Okay, so and to be amphiprotic, you have to do both.
You have to do both. That's what amphiprotic means. Yeah. Amphi is the same word that became the root ambi. So you've heard of ambidextrous. You can use both hands. If you said amphidextrous, it would be the same thing. You can do both of them. Last one. In which of the following reactions is water behaving as an acid? Yep.
Bottom left.
Oh, you were answering right away. So we've got one of them. Why is it behaving as an acid there?
Because it is giving away.
Giving it away. Is there any other ones? So let's go acid. Check out the other ones. What water is acting as?
What's the velocity, Lowry?
Proton donor.
Okay, it was just running with OH.
Samuel, Josh, this isn't a computer one. You can put away your phones.
Why is it acting like that?
What's it doing there?
Oh, giving it.
Giving up. And what is ammonia doing there? Taking. So that's the base, that's the acid. And then you get the acid and the ultimate base.
If there's H2O in the reactants and OH in the products, is it always like that?
Yeah.
Okay.
So for these ones, what's water acting as?
A base.
A base. Because it has to accept the protons. And then you get H3O plus. So it's acting as a base. These are your acids. These are your conjugate bases. And these are the ultimate acids. What is water acting like in this one? Water in this one's acting as an acid, so there's our answer. It's acting as a base in both of these, so that's wrong. What is water acting like in this one? Proton donor, proton acceptor. Pardon? Totally nothing. Yeah. Well, it is doing something. This is a redox reaction,
Do we not do that?
and the hydrogen in this case is gaining electrons, and so the water is both acting as an oxidizer and a reducer at the same time. So essentially, in this one, water is acting crazy and doing nothing, according to us. At this point. Yeah, it's just there to confuse you.
Does that reaction exist, the redox one?
This one?
Did it happen? Yeah.
Yeah, all the time. It takes energy, but this is how we generate hydrogen and oxygen gas. Just you can do it. Take a 9-volt battery, put 2 electrodes on it. So like, or you can just stick the 9-volt in a cup of water. Make sure it's a little salty, and you'll see bubbles falling off of each eye, and you're generating hydrogen and oxygen gas. If you collect the bubbles, you'll notice you'll generate 2 times as much gas as the other one, and that's your hydrogen side. Okay.
You good? Good, yeah.
Before you go.
Wait, so you've
Yep.
we put a battery in salty
You
water
guys need.
and we catch it in like a balloon.
You need one?
No.
Okay.
So, so if we do that and we catch it in a balloon,
Yep.
we could make a bomb out of it.
Yeah, it's slow, but people have collected hydrogen and doing home experiments and blown it up in their base since time immemorial. Like a rite of passage.
Thanks, dude.
You're welcome. There you go.
You'll see some of that.
Pardon?
Oh my gosh.
With a 9-volt battery, you don't generate energy.
Well, I'll just buy out of it. Yeah.
Yeah, you gotta get something that'll step it and
Battery.
car battery. You also need the right voltage. But it's more about the amperage too, not the voltage.
Oh.
You get the amount, because you're just moving electrons. Thank you.
We have to break into physics now.